In this video, I'm going to model some of these simplifying exponents problems for you before you start your practice. So for our very first one, we've got b cubed times c to the fifth, and that's one quantity. We're going to multiply it times negative 2, b squared times c to the negative 2 power, and that's all divided by 3, b to the fourth, c squared. So the very first thing I'm going to want to do is address the negative exponent on the top. So I've got this quantity, this is my base. This base is being raised to a negative exponent. When we have negative exponents, we're going to remember move it to the other side of the fraction, and the exponent is going to become positive. So when I look at that, that really means on the next line I'm going to have b cubed c to the fifth over 3b to the fourth c squared, and then I'm moving the whole base, all of the base, to the bottom, and the exponent, the negative 2, is going to become positive 2. Once I do that, I'm going to look at, again, I've got this whole quantity right here that's being raised to the second power. And an exponent of 2 means that I'm taking the base and I'm multiplying it times itself 2 times. So on the top I still have b cubed c to the fifth power. On the bottom I have 3b to the fourth c squared. And then I'm going to rewrite this with what I know that it really means, which is taking the base and writing it out 2 times. And 2 times comes again from the exponent of 2. From here, make this a little bit smaller. From here I'm going to start combining across the top if I can, and across the bottom if I can. On the top there's nothing that is alike, so that's going to stay as b cubed times c to the fifth power. On the bottom I'm going to multiply first my coefficients. 3 times negative 2 times negative 2. 3 times negative 2 is negative 6. Negative 6 times negative 2 is positive 12. And then I'm going to start thinking about how many of each variable I have. So if I were to expand b to the fourth out, I'd really have b times b times b times b. And if I were to expand b squared, I would have b times b. And another b squared is going to be b times b. So if I count them all up, I have 1, 2, 3, 4, 5, 6, 7, 8. That's going to be b to the 8th power. If I'm looking at the c, if I were to expand c squared, I'd have c times c. I've got another c, that makes 3 of them total. If I count this one, that makes 4 of them total. So I have c to the 4th power. Finally, what I'm going to do, so now I've got it simplified across the numerator and I've simplified across the denominator. Now I'm going to start looking at simplifying across that fraction bar. When I do that, I'm going to think about b cubed as b times b times b. And I'm going to think about c to the fifth as c times itself 5 times. 1, 2, 3, 4, 5. On the bottom I still have the 12. I have b to the 8th power. One, 2, 3, 4, 5, 6, 7, 8, and I have c to the 4th power. So this is what I have, and I'm going to start looking for my fancy ones. So if I have one on top and one on the bottom, it creates a fancy 1. Once I've got all these pairs, that's a fancy 1. 1 times anything is itself, so I can mark it off. And then I have some more fancy ones with the b's. And now I'm looking for what I have left. So on the top, the only thing I have left is a c, so the numerator is going to be a c. In the denominator, I have 12, and I have 1, 2, 3, 4, 5 b's, so that's going to be 12b to the 5th power. So my final answer for this one is c over 12 times b to the 5th power. Okay, the second question on the diagnostic that I'm going to model for you, looks like this. So in the numerator, using what we just talked about, in the numerator I have a base, so this whole thing is the base, and it's being raised to the third power, which means when I rewrite it, I'm going to rewrite that 3 times. In the denominator, I have a plain old 3 that has a positive exponent of 1, so that's going to stay in the denominator. And then I have a base that's being raised to a negative exponent. I'm thinking about what we learned before. If we have negative exponents, they are going to move to the other side of the fraction, so we're going to take the reciprocal, and that exponent is going to become positive. So I'm going to have x cubed y, that quantity, except my new exponent's going to be a positive 2 instead of a negative 2. So rewriting my numerator, I've got 3y to the 4th x times 3y to the 4th x times 3y to the 4th x times x cubed y times x cubed y. So, and again, this part is coming from the fact that I've got a base being raised to an exponent of 2. In the denominator, I just have a plain old 3. So that part's easy. When I look at this, I can think about the 3 in the denominator and one of the 3's in the numerator as creating a fancy 1. If this is a fancy 1, they're going to simplify, and I won't have either of those anymore. If I look at what's left, so there's nothing left in the denominator, which means it's going to be a little invisible 1. I can think about it a 1. I've got 3 times 3, which is 9. And then if I start counting things, I have 1, 2, 3 x's. I've got 3 more x's here, so that makes 6 x's. And then I've got 3 more x's here, that's going to be 9. So if I wrote them all out together using these exponents, I would have x to the 9th total. If I look at the y's, I have 4 y's here, plus 4 more makes 8, plus 4 more makes 12, plus 1 makes 13, plus another one makes 14. So that's y to the 14th power. So simplifying that takes care of everything. I'm just going to have 9x to the 9th, y to the 14th.